Okay, so just thought we would do a little bit of a review of conceptual stuff. I don't know if you've taken a look at your practice final, and just want to say, probably something very important is being able to distinguish between what kind of statistical inference scenario you are dealing with, okay? Scenario we have, okay? And there are technically 7 that you are responsible for. They're all listed on that formula sheet. Confidence intervals for P, hypothesis test for proportion 1 sample, hypothesis test for proportions 2 samples, confidence intervals for means 1 sample and 2 samples, hypothesis test for means 1 sample and 2 samples. Okay, so they're all listed on that formula sheet, and so just wanted to give you some guidelines, tips to decide, how to determine what type of problem it is. Okay, so first you want to decide, am I dealing with proportions or means? Okay, proportions or means. So it's proportions if, in the problem it says proportions, okay? We'll say, okay, if you see keywords, keywords like proportions, percentages, okay? Or if the data is provided as counts, data is provided as counts. The other thing that will tell you that it's proportions, well, the overall part is you have a categorical variable. Okay, so if you have a categorical variable, it's going to be proportions. And you'll see keywords like proportions or percentages, and the data is going to be provided as counts. Okay. On the other hand, you have means. This means if, I guess we'll start off, you have a numeric variable. Okay. And then you have keywords such as the mean, average, or the data, as far as the data being provided is, you'll see a standard deviation, okay? Okay, if you see standard deviation in there, you're going to have, it's going to be a numeric variable, and you're dealing with means, okay? So that will help you decide whether you're dealing with kind of the upper ones, which are proportions on that formula sheet. The top 4 boxes are for proportions, and the bottom 4 are for means. Okay, so decide if you got proportions or means. Then you need to decide, am I dealing with confidence intervals or hypothesis tests? I think this part is a lot easier to distinguish, but for confidence intervals, you're going to see things like confidence level, okay? So that's listed. Anything about margin of error or anything about an interval will indicate that you're dealing with a confidence interval situation. So these are kind of the keywords. As far as hypothesis tests go, clearly saying hypothesis will mean that you're dealing with a hypothesis test. Test statistic or p-value. These only apply for hypothesis tests. Okay? You don't have p-values for confidence intervals. You don't have test statistics for confidence intervals. Okay, they only exist in the context of hypothesis tests. So as you're going through the problem, these are kind of the things that distinguish between confidence intervals and hypothesis tests. Other questions, those can apply to both. Things like, do we have evidence of this? That applies to both a confidence interval and a hypothesis test. So that question will not distinguish. But whether, if it asks for a confidence level, margin of error, or interval, that's a confidence interval situation. Test statistics, p-values, and hypotheses are for hypothesis tests. Let's see. I guess I can copy this into a lecture slide here. All right, and then finally, one sample or two samples. Okay, the key here is go through the problem and see how many ends you can identify. Okay. Okay. If you can only identify one n, one sample size, then you're dealing with one sample. Okay. But this part of figuring out whether, what kind of scenario you're dealing with, this is, I can't overstate how important it is, because if you mess this part up, you're going to be using the wrong set of formulas, and then that whole section is going to be wrong, okay? So, all right, got it. Sorry. Slide this over. Okay. So we'll just do a few quick. All right, so I've got a few questions prepared here. You don't have to. All right, so we'll start off with the first one here. It says a researcher wants to know if the rate of teen pregnancy has changed, and we'll say in 1995 the rate was found to be 8%, and a recent study surveyed 1,200 randomly selected female teenagers and found that 103 had teen pregnancies. Okay. Okay, so yeah, we won't do a clicker question here just yet, but yeah, write down. Do we have one sample, two samples, means, proportions, hypothesis tests? Oh wait, I guess I haven't. There's nothing about that will distinguish whether it's a hypothesis test or confidence interval. Okay, so there's only. So you can't decide if it's a confidence interval or hypothesis test, but the rest is what? This would be proportions with one sample, right? Okay. I have this. Okay, and then over here it says a teacher wishes to know if the performance of his students has changed between quarters. Last quarter there were 150 students in his class. The average grade was 87% with a standard deviation of 12%. This quarter he has 160 students and the average grade is 90% with a standard deviation of 10%. This would be don't feel like you have to write all of this down, okay? I think you'd be too hard to, I don't know what's going on here. Copy, paste. Okay, something happened here. My screen is not working. Okay. Well, anyway, that's means with 2 samples. All right. I'll just put the answers here. Okay. All right. So we'll do some. Now we'll do some actual questions here. All right. I'll just put these, and then I'll get the answers posted onto CCLE. Okay. So. Let's do some questions for inference. This will be confidence intervals. Are you guys all able to read the screen here? Do I need to make it larger? I don't know how much. Okay, I think this is about as big as. All right, so our first question says, you create a 95% confidence interval for mu. The interval goes from 1.2 to 3.5. This is the interval for mu. And so the question is true or false. True will be A, and false will be B. Apparently, thinks that's a smiley. Okay. Our confidence interval provides evidence that the population mean is not 0. What is that? Okay. We should work fairly quickly through all of these. Okay. I'm going to go ahead and click stop soon. So you got like 10 seconds to get your click in. Okay, hit stop here. And we've got true. True is the correct answer there. Okay, I think. All right, what about this one? I don't want to run the clicker for every single thing. Okay, true, false. Our confidence interval provides evidence that the population mean is not 2.5. Okay, again, the interval goes from 1.2 to 3.5. Confidence interval provides evidence that the mean is not 2.5. The answer here is false. Okay. Okay. Our confidence interval provides evidence that the population mean is 2.5. False. Okay. There's a 95% probability that the population mean is between 1.2 and 3.5. That's true. Should we do a clicker question here? We'll do a clicker question for this one. Okay. Put this in the brackets here so I don't get a smiley face here. Okay, so for this one, about the 95% probability. Confidence interval. The interval goes from 1.2 to 3.5. True or false? 95% probability that the population mean is between 1.2 and 3.5. Okay, I'm gonna go ahead and click stop here. Just to get your clicks in. Okay, let's take a look. Okay, here we are. And the answer is B for false, okay? Confidence intervals. Do not tell us about probability, okay? Because there's no probability associated with the mean mu, okay? The mean mu is a fixed unknown value, and there is no uncertainty about it, okay? So no probability associated. No probability associated with the mean mu. Okay. True or false, 95% of the values in the population are between 1.2 and 3.5. 95% of the values in the population. Should we do a clicker question here? Sure, why not? Okay. Okay, so A or B. A for true, B for false. We create a 95% confidence interval for mu. The interval goes from 1.2 to 3.5. True or false, 95% of the values in the population are between 1.2 and 3.5. You can talk to your neighbors if you need to. Okay, I'm going to go ahead and click stop here to get your clicks in. Okay, let's see how you guys answered. And the answer is indeed B, false, okay? So the interpretation would be, I am 95% confident that the population mean mu is between 1.2 and 3.5, okay? The interval is not about values within the population itself. So the population could have values all over the place, right? So for example, if we're talking about median income in the United States or mean income in the United States, I'm pretty confident it's between $50,000 and $70,000, okay? However, do 95% of people in the United States make between $50,000 and $70,000? No, you've got much more spread, and you got a lot of people making below that range and a lot of people making above that range. And so, as far as the mean of the entire population, yes, we can be quite confident that that it's going to be between 50 and 70, something around there. But there's still a lot of people outside of those ranges. Okay, so it's not correct to say that 95% of values in the population are between 1.2 and 3.5. Okay. True or false, 95% of samples will have sample means between 1.2 and 3.5. 95% of the samples will have sample means. All right, I won't do a clicker question here. We'll just, I'll give you the answer. The answer here, again, is false, okay? The confidence interval, the interval is about our confidence regarding the mean of the population. Okay? And future sample means, okay, so what is true, okay? What is true is that 95% of samples will have sample means close enough to mu that the confidence interval will contain mu, if that makes sense. So 95% of samples will have sample means close enough to mu that the confidence interval will contain mu, okay? But it's not that 95% of samples will have sample means between a particular range, okay? If we knew the population mean, we could say 95% of samples will be between, 1.96 above the population mean and 1.96 below the population mean, so that the resulting confidence interval will contain mu. But we cannot say that 95% of samples will have sample means between this value and this value. Is that okay? I'll post all of these text questions, so don't feel like you have to I don't know, write down like super fast all of these things here. Okay, we'll try this one. True or false? Okay. If 100 samples were drawn from the population and each sample produced a 95% confidence interval, we would expect 95% of those confidence intervals to capture the true population mean. If 100 samples were drawn from the population, I should say 100 random samples, and each sample produced a 95% confidence interval, we would expect 95% of those confidence intervals to capture the true population mean. Yes, no, okay. How are we feeling? Okay, just a couple more seconds here. Go ahead and I'm going to go ahead and click stop here. All right, let's take a look. Okay, everyone's unsure about everything. Okay, and the correct answer is true for that one. Okay, so yes, this is kind of this is what the 95% and the 95% confidence interval means. It's just that when we make a confidence interval, we expect 95%, 95% of 95% confidence intervals should capture the true population mean. Of course, when you make your one confidence interval, you don't know if it's part of the 5% or part of the 95%. You're kind of banking on the fact that 95% of the time it's in the 95%. But you don't know, but that's why we say, I'm 95% confident about my result. Okay, so the answer here is true. Okay, is that okay with all of this confidence interval stuff? This is all right. Okay, we'll All right. Can do more questions. Is this like torture? I don't know. I think it's good conceptual review here. Okay. And all right. So we'll do some questions about hypothesis testing then. Okay. We'll say these are your answer choices for this question. Vitamita Vegemin, did you guys ever see that I Love Lucy episode? Okay, all right. All right, so it's a fictional thing, but all right. Okay, it says you perform a hypothesis test to see if the proportion of people who like, some product, which we'll call Vitamita Vegemin for this example. We want to see if the proportion of people who like this is less than 75%, is less than 0.75, okay? We went ahead, we'll say we did all of the math. The resulting p-value for this test is 1%, and we used an alpha of 5%, okay? So what is the statement, which statement would we say is true? So your possible statement choices are: we have evidence that the population proportion is 75%, or B, we do not have evidence that the population proportion is 75%. We have evidence that the population proportion is less than 75%, or we do not have evidence that the population proportion is less than 75%. Maybe I should say pick the best answer. Okay, I'm gonna go ahead and click stop here to get your clicks in. Okay, all right, let's see. Let's see how you responded. And the correct answer is indeed C. Okay, so what's going on here is the null hypothesis would be that P is equal to 75%, and the alternative would be that P is less than 75%, okay? And what we did was, with p-value being 1%, the p-value is less than alpha, so we reject the null hypothesis and say we have evidence to support the alternative. Okay, and so in that case we say we have evidence that the proportion is less than 75%. Okay. So is that good? Are there any questions? Oh, okay. Now I guess I gave the answer away for this one. Okay, well, all right, so it says you perform the same question as before. You perform a hypothesis test to see if the proportion of people who like Vitamita Vegemin is less than 75%. The p-value for this test is 1%. You used an alpha of 5%. Which statement is true? And this would also be C. You have evidence to support the alternative. Okay. Okay, so this one, the answer choice is C. Yes? You do not have so B is, this is, how do we say? Because the evidence is always used either to support the alternative, or it's always used to argue for the alternative. So for example, in a criminal trial, okay, it's the prosecution's job to present evidence to convince the jury that the defendant is guilty, okay? And so the jury would say, we found the evidence convincing, we found it convincing enough for us to conclude that the defendant is guilty. We don't say that we have, so we would say we have evidence supporting the defendant's guilt. We wouldn't say we have evidence, we would not say that we don't have evidence of innocence, if that makes sense, okay? Because the evidence is always presented towards the alternative, okay? So having evidence to support the alternative means that there is evidence, there is data that supports this, okay? It's not that we lack evidence, okay, that we are missing evidence supporting the null, because we're not looking for evidence. That's not how the thing works, if that makes sense, okay? So so while this might be true, that I'm trying to figure out how to articulate this properly, but we don't use the evidence to support the null, if that makes sense, okay? So we assume that the null is true, and if there's no evidence, if there's not enough evidence provided, we just say, okay, then we're going to default with the null. If the prosecution doesn't provide enough evidence, we're going to say we don't have enough evidence to convict, and we're going to acquit the defendant. Okay. I hope that's all right. I guess these are all kind of related here, and we'll say, so it says, we perform a hypothesis test to see if the proportion of people who like vitamin A vegemin is less than 75%. Okay, so here, instead of the word support, we're using the word reject, okay? So we'll run an actual question here. So same scenario as before. P-value is 1%. We used alpha of 5%. And which statement is true here? We have evidence to reject. We do not have evidence to reject the null. We have evidence to reject the alternative, or we do not have evidence to reject the alternative. And I guess all of this, just pick your best answer, because some of these might be like technically arguably correct, but not the best answer that we're going for. Okay, I'll go ahead and click stop here, and the answer is A. Some of you selected D. Okay, again, this is kind of we don't reject the alternative, okay? So when we're talking about rejecting a hypothesis, we only reject the null. So the correct answer here is A. Rejecting a hypothesis only applies to the null hypothesis. Okay? We don't we never actually reject the alternative. Okay. So we don't say we didn't reject or we do reject the alternative. We only talk about rejecting the null hypothesis. And so that's so if we're talking about the criminal trial and the defendant, we can say we're rejecting the idea that the defendant is innocent. Okay. However, we don't say we didn't reject the idea that the defendant was guilty, because we didn't start off with the assumption that the defendant was guilty. We start off with the assumption that the defendant is innocent, and it takes evidence for us to reject that assumption. Okay? We're not starting with the assumption that the defendant is guilty. So we don't say that we didn't reject the alternative. Okay, we'll do just a couple more of these things. I won't run clickers here. Okay, it says we want to create a hypothesis test to see if the proportion of North Campus students who read novels for pleasure is greater than the proportion of South Campus students who read novels for pleasure. Okay, so we'll say North Campus students will be population 1, and South Campus students will be population 2. Okay, so what would the appropriate hypothesis be where exclamation equals means not equal? 2. Okay. Okay, so do we say that so what would we choose? Okay. Okay, so the keyword here is greater, okay? And so the correct answer choice is C. Okay, and that's because the null hypothesis always has an equal sign. And then the fact that the question suggests a one-sided test, okay, or the question has greater, meaning we expect the proportion P1 to be greater than P2. Okay, that's what we're testing for. So we're going to use answer choice C for our hypotheses. Okay, here's a question on type 1 or type 2 error. Okay, it says doctors. I guess we'll run a clicker question here. Okay, it says doctors can administer an STD test. The test would assume that the person is STD free unless they show symptoms of having a disease. The null hypothesis will be the patient is disease free. The alternative is the patient has an STD. All right, so what do we want? Is type 1 or type 2 error worse? Do we pick a large alpha or small alpha? Okay, go ahead and click your answers. I'll click stop here. Okay. All right, let's take a look at how you guys responded. And indeed, C is the correct answer. Okay. So in this context, a type 2 error. Type 2 error would be a person has a disease, but the test says no disease. Okay. This could potentially cause, could potentially lead to, lead to the disease spreading. Okay. And so, so this is worse. So type 2 error is worse than type 1. Okay. So we would rather make type 1 error and use a large alpha. Okay? Because a small alpha would mean we avoid type 1 error, but the cost of avoiding type 1 error increases the risk of type 2 error. Yeah, question?
So is type 2 error always worse than the type 1?
No, that's not always the case, okay? Because in the case of the criminal trial, we said the type 1 error is worse than the type 2. Type 1 would be convicting an innocent person for a crime they didn't commit, and we said that would be worse. I mean, debatable, but that would be worse than letting a guilty person go free. Yeah. How are the judgments made regarding this? I guess, I mean, how are the judgments made? Okay, I think in certain cases it will be clear. I mean, I'm trying to think where type 1 error in this case would be worse than type 2. I think I think the example I'll use in the final exam will be clear, and if you're not sure, during the exam, you can ask me a question, and if you can properly articulate what the type 1 error is and what the type 2 error is, and if you truly are like, I can't tell if it's worse to do it this way or worse to do it that way, I can say, well, it's worse this way, but you have to be able to articulate what the type 1 and the type 2 error is, and I think at least on the exam it will be quite clear. I think in this case it's still pretty clear that the type 2 is worse than the type 1, but for the individual being tested, yeah, type 1 errors is no good, but I think if you're the individual and you made the type 2 error, I think you'd also feel really, really, really bad, right? Like, so I think that I think the type 2 is worse. Okay, we'll end here, and we'll see you guys on Friday. So good luck as you guys continue studying and for all of your other classes.